Hello, my name is J.R. Garcia. I am a Solutions Engineering Director here at ANM, and I'm here to talk a little bit today about segmentation. Now, segmentation is one of the most effective tools that you can use to limit lateral movement on your network to prevent threats going from host A to host B. So traditionally, the way that we segmented networks over the past many years is by using VLANs and subnets. So you kind of draw out a typical network design here. We've got like a core or distribution, our access layer, activity here. If we wanted to filter traffic between these two hosts, say it's VLAN 1, VLAN 2. We have two hosts, two different VLANs. Let's say we want to implement a security policy that blocks certain traffic between VLANs 1 and 2. Typically, what we would do is implement, put these hosts in different VLANs, trunk those up to some sort of a firewall, and then apply our policy up here. So once we get the traffic up to the firewall, then the firewall then has a policy that either permits or denies that particular traffic. Now, this works great. However, in one particular use case, let's say we want to filter traffic between hosts on the same VLAN. So we have a different host over here on that same VLAN 1. Now, because these two hosts are on the same VLAN, the firewall never sees that traffic, right? It sits here on the same network. That traffic does not get forwarded to the firewall and back down again because it's in the same layer 2 domain. So this effectively causes a very large blast radius, meaning if this host were to be compromised, there's unfiltered east-west connectivity between these two hosts, and we could potentially compromise this other one here. So how do we solve this problem? Enter microsegmentation. Now, what microsegmentation does is it effectively pushes a policy that would typically live either on the firewall or some other layer 3 boundary down closer and closer to the application or to the end user, so that if one particular host or endpoint is compromised, it doesn't have full connectivity to other devices on that same network. Now, there are 3 methods to do microsegmentation. The first one being network-based. Second is hypervisor. And the third is agent-based. So let's take a look at both. So again, got the same scenario. Let's say we've got 2 networks here, 2 hosts, I should say, on the same VLAN. All these VLAN 10, right? And our security department has told us that we need to filter traffic between hosts on this same network. Let's say this is our Crown Jewels, our billing application, where if this goes down, we're losing a bunch of money. So we want to make sure that this is up and that attackers can't get to other devices on this segment of the network. So how do we do that? So if we go through these options, let's take a look at network first. What network-based microsegmentation does is it effectively implements a security policy on the physical port or the virtual port of where this host connects to. This is generally done through like an ACL, SGACL, or something of that nature, right? So now, instead of having to hairpin that traffic all the way up to the firewall and back down again, we're now blocking that traffic closer to the application. This is very popular in SDN solutions, specifically in the campus, because of things like IoT devices, where you can't, install an IoT device on a hypervisor or put an agent on it. We have to apply some sort of security on the physical switch port for things like IoT. Secondly, hypervisor. So if we expand this box a little bit, make this host a little bigger. hypervisor-based segmentation. On this host, there's a hypervisor installed, typically VMware. And what hypervisor-based microseg does is it installs a VNIC level firewall on the virtual machine. And on that VNIC level firewall, then we can implement or turn on additional firewall features like IPS, IDS, content filtering, layer 7 filtering, all the fancy features that physical firewall would typically have. Now we've pushed that down closer to the host. And so if this host is compromised, now we're blocking that traffic directly on the hypervisor level versus, again, hairpinning it up to firewall. Lastly is agent-based solution. So on this virtual machine, there's going to be some sort of a guest operating system running on it, Windows, Linux, something like that. And what this does is the agent gets installed on the operating system, and now we've got operating system level visibility and operating system level security on that host itself. So what these guys will typically do is either orchestrate the Windows firewall to either permit or deny traffic, or it'll modify Linux IP tables to for the security policy. Additionally, we also get process level visibility into what's going on that operating system. So now, again, if we look at the same scenario here, let's say this host gets compromised. Now, there are multiple ways to block that compromise. So if a malicious actor were to try and access this host, if it were to gain access to this one, now there's a couple different ways that we can block that traffic, either through the network via microsegmentation on the network, or the hypervisor, or down even on the OS level. ANM has a rich history in network engineering and has a lot of experience both in your traditional network segmentation methodologies, but also these newer microsegmentation ones. So if you want to learn more, or if you think this could be a fit, makes sense on your network, send an email to info@anm.com or contact your local ANM account team. Thanks.